Today we are working on solving equations. So this first example here, we've solved these within our last unit. What we would do is we would take our 1/8 and we would rewrite it so that it was 2 to some power. What would be our power for that one? 2 to the negative 3. Because the negative exponent is what makes it the fraction. 2 to the third power is what gives us the 8. And so then once we had that same base, what would we do? Yes, our exponents were then equal. So we would get x equals negative 6. So this is what we would call our change of base. When we had x in the exponent spot, we would use our change of base formula in order to figure out what x ended up equaling. The only kinds of problems we didn't run into were like ones with example B, 3 to the x equals 5. We didn't do those ones because can we change those so that they have the same base? No, can't do that with a 3 and a 5. So the other way that we can solve this to get x out of the exponent spot is we are going to take the log of both sides. Whenever you have two bases that you can't get equal to each other, you're going to take the log of both sides. So looking at that example, 3 to the x equals 5. So what that would look like is the log of my left side of 3 to the x equals the log of my right side, which is 5. So I take the log of both sides. Doing that then creates it so that they have the same base now because they're both log base 10. Using our exponent rules, what happens to my exponent of x there? Comes down in front, so now it's no longer in the exponent spot. We have x times the log of 3 equals my log of 5. Since it's x times the log of 3, I would divide by log of 3. So we would have x equals the log of 5 divided by the log of 3. This is what we would refer to as the exact value. So if you were asked for the exact value answer, that's what they would be looking for. And this one would be log 5 divided by log 3. Go ahead, type that in your calculator. Let's get our answer to the nearest thousandth. Log of 5 divided by log of 3. So 1.46, I believe it rounds to 5, right? All right, so let's take a look at our next one. So this time we got 9 to the 2x plus 1 equals 15. Same thing, let's get that 9 by itself first. So I'm going to subtract my 1. So I have 9 to the 2x equals 14. Now again, I can rewrite 9. I can rewrite it as 3 squared, but I can't do that for the 14. So we're going to take the log of both sides. My exponent of 2x comes down in front of my log of 9. So we get 2x times the log of 9 equals the log of 14. So what do we have to divide by to get x by itself? 2 and the log of 9. We got to divide by both of them. And then that one cancels. We'd have just the x on my left side. Again, exact value, if they asked for it, would be this, log 14 over 2 log 9. But our direction said to the nearest hundredth, so go ahead, practice typing that in. Log 14 divided by 2 log 9. See what we get to the nearest hundredth. That's not what I had. Yeah. Next example over here, 100 equals 300 times 1.6 to the 2x minus 1. We have to get the 1.6 by itself because that's what has the exponent. So how do I get rid of my 300? Divide. So then we simplify the 100 over 300. Don't write it as a decimal because you're going to end up rounding it. We don't want to round so early, so leave it as 1/3. So now we're going to take the log of both sides. Because your exponent is a binomial, you want to put it in parentheses. So it's parentheses 2x minus 1 times the log of 1.6 because it's that whole exponent times that log. So trying to get x by itself, so I divide by the log of 1.6. So the log of 1/3 divided by the log of 1.6 equals 2x minus 1. So what would we do first to try to get x by itself? Add 1. So the 1 would be added to the whole fraction there of the log. So you would put it at the end there. And then you would divide everything by 2. So this is our exact value answered here for this one. That one's a little bit nastier one. So go ahead, type it in. Get your decimal to the nearest 10,000th. Should end up with a negative. Negative 0.6687. Next one. 2 to the x plus 3 equals 1/8. I know we already solved that up above, but we're going to practice doing it using logs. So we're going to take the log of both sides. So x plus 3 times the log of 2 is going to equal the log of 1/8. So divide by the log of 2. So after we divide by the log of 2, what do we do with that 3? Subtract it, because it was plus 3, so we want to subtract it over. So type that in, the log of 1/8 divided by the log of 2 minus 3. Doesn't look like an 8, but that's an 8. 1/8. Log of 1/8 divided by the log of 2, and then subtract 3. What do we get? Negative 6. So then I throw ones like these last two in here, not to try to confuse you, but to try to help you look through this. Do I need to do anything to that? No, what can we do? Just put it in the calculator. So go ahead, type in the log base. See what we get to the nearest 100th. What do we get? 0.80. For letter B, what's the one thing we have to do? Divide by 0.08. So you could use your log base for the top part and then divide it by 0.08. And you hopefully get 27.58. All right, backside still doing the same thing, only this time we have a base of e, which means we're going to use what instead of logs? ln's. E is special, it gets its own letters. So first thing we would have to do is divide by the 3. So we get e to the x minus 5 equals 2. Get the e by itself. So then we're going to take the ln of both sides. So our exponent still comes down in front. So x minus 5 times the ln of e equals ln of 2. But again, what does ln of e simplify to? 1. So I'm going to just go ahead and cross that out because it just simplifies to a 1. So that's going to stay as x minus 5 on that side. So then we add our 5 over. So our exact value is ln of 2 plus 5. It asks, though, for the nearest thousandth, so go ahead and plug that in. Make sure you remember to close the parenthesis after the 2. So 5.693. Letter B there, what should we do first? Subtract 7.4. So I subtract my 7.4, I get negative 4.7 equals negative e to the 0.032x. Now what should we do? Divide by negative 1, yeah, because we can't do ln of a negative. So divide by negative 1, it makes both sides turn positive. So then we take the ln of both sides. So the ln of the 4.7 equals 0.032x times the ln of e. But again, what happens to ln of e? It becomes a 1. So divide by 0.032, and what do we get to the nearest thousandth? .361. So whether you're using logs, ln's, process is still the same. So then I get asked a lot when we're doing these whether it actually matters if you use logs or ln's in order to solve these kinds of equations. So we're going to kind of take a look at that, see what happens. So looking at our first one, 4 to the x equals 173. We'll solve that first using logs. So we're going to take the log of both sides. So we get x times the log of 4 equals the log of 173. And then what do we divide by? Log of 4. So go ahead, type that in your calculator, and let's get a decimal to the nearest thousandth, because it's easier to compare the decimals. 3.717. So now let's use ln's and see what we get. So instead of taking the log of both sides, even though I don't have a base of e, I'm going to take the ln of both sides. So very similar, x of ln of 4 equals the ln of 173. Divide by the ln of 4. And what do we get? Same thing. So it does not matter when you have numerical bases whether you use logs of both sides or the ln of both sides. Anybody willing to venture a guess as to why? Kind of. These got turned into base 10 once I took the log of it, so it made them the same base. When I used ln, turned them both into base of e. So no matter what the base is, I turned them into the same base. So it worked out for both situations there. Let's see if it holds true when your base is already an e. So let's start off with log. I'm going to take the log of both sides. So the log of x times the log of e equals the log of 51.8. So divide by the log of e. Use your calculator and let's see what we get for a decimal. What do we get? 3.947. All right. So now let's try taking the ln of both sides. Again, what happens when I have ln of e? Goes to 1. So really all you have to type in your calculator is the ln of 51.8. 3.947. So does it really matter? No. ln, does it just make that easier when you have e? Yeah, because I mean that just cancels out and then you just got less to type in the calculator. So I mean ln's are easier when you have a base of e, but either one really works, so it really does not matter. And then we should already hopefully know this answer. Can we actually graph log base 3 of x in our calculator? Yes. Do you guys know the shortcut to get there? If you hit alpha window, it gives you a shortcut to a whole bunch of different things. You got absolute value in there, summation, which we're going to do in a few units. But your fifth option there, that's your log base. So it's just a little shortcut to make it go faster. And then it opens up your log base for you. So if you want to type that in your notes, alpha window number 5 is a shortcut to your log base. All right, we got 2 other types of equations we're solving. All right. If you have log written on both sides of your equal sign, first thing you'll do is you'll condense it down so that you have log written once on each side. So if you have more than one log, using your condensing rules, make it just so there's one. So once you have it so that you have log of something equals log of something, you then cancel out your logs. and then you solve and check. So looking at our first example there, I have log base 2 of 2x minus 1 equals log base 2 of x plus 3. I have one log on each side of my equal sign, so I can just cross them out. So now I have the equation 2x minus 1 equals x plus 3, and we just solved that one now. So I subtract my x over, add my 1, and we get x equals 4. So if you have a log on both sides, they cancel each other out. One thing to note when you're checking, you cannot take the log of a negative. So that's pretty much all you're checking for, is if you take your answer and you plug it back into the original, are you taking the log of a negative number? So my 4, if I plug it in here to the 2x minus 1, I'd get a positive 7, so that one's okay. If I put it over here, I also get a positive 7, so that one's okay. So we get to keep x equals 4 as our answer. All right, example 2, I have 2 logs on my left side, so we have to condense it. So what's really happening between that 4 and that 6? They're being multiplied. So we got log base 3 of 24 equals log base 3 of x. So now I have 1 log equals 1 log. They cancel. So 24 equals x. And then my quick little check, if I plug 24 back in here for this x, am I taking the log of a negative? No, taking the log of a positive 24, so we're all good. Number 3, again, we're going to be doing a little bit of multiplying over there on that left side, so I would have x times x plus 5 equals the log of 6. So now I have 1 log on my left side, 1 log on my right side. They cancel each other out. So I get x squared plus 5x equals 6. I distributed my x through. All right, so we're going to have to factor because I have an x squared in there. So I want to subtract my 6 over. So what multiplies for negative 6 adds to give us 5. No. 6 and 1. Positive 6, negative 1. Multiplies to give you negative 6, but would give you a positive 5 in the middle. So I get 2 answers of negative 6 and positive 1. However, if I take my negative 6 and I plug it in for this x, I'm taking the log of negative 6. I can't do that. Can't take log of a negative. So your only answer is x equals 1. No. All right, fourth one, condensing rules. If I'm subtracting, that means what's really happening? Division. So it's x squared plus 5x minus 14 divided by x plus 7 equals the ln of 8. So now I have ln on one side, ln on the other side. So they cancel each other out. A few different ways we can go about solving this. One way is easier than the other way. That's not the easier way. Factor the top. That would factor into x plus 7 times x minus 2. So once I factored it, what happens? The x plus 7's cancel, so x minus 2 equals 8. X equals 10. And then again, quick little mental check. If you plug 10 in, do we get any negatives up there?
No.
Number 5, again, subtracting. So that's division. So I have the ln of 75 divided by x equals the ln of 25. My ln's cancel. A couple different ways again that we could solve this one. So what are you guys seeing? What should we do? I mean, you could put this as over 1 and then cross multiply. Other people say multiply both sides by x, which also works too. So divide by 25 and we get x equals 3. So last kind, solving when you have log on one side. We've actually done some of these before. These ones are just a little bit more difficult. Same first step, still condensed to a single log. So you'll have log written once on one side, a number or letter on the other side. So then you would put it in exponential form. So since you have log written once, we would rewrite it in our other form, our exponential form. And then solve and check. So looking at my example in the box, what's happening between the x and the x minus 8? They are being multiplied, so x times x minus 8. So I have log base 3 of x times x minus 8 equals 2. So now we're going to put it into exponential form. What's our base? 3. Our exponent? 2. And it's going to equal x squared times 8x when I distribute. Yes, because it was minus 8. So 3 squared is really a 9. So I'm going to change that to a 9. So then I'm going to subtract my 9 over, because again, we are going to factor. So 0 equals x squared minus 8x minus 9. What factors would we use here? X minus 9 and x plus 1. So we get 9 and a negative 1. Do we get to keep both of them? Do we reject one? What do we do? Reject the negative. Now be careful. You're not always going to reject the negative number. Sometimes it stays. If you plug it back into the original, if it makes a negative, it goes. All right, 3 more examples. ln of x plus ln of 1. What's happened between the x and the 1? Multiply. So it'd be ln of x equals 5, because x times 1 is 1, or is x. Exponential form, what's our base? E. Our base is e whenever we have ln. So e to the 5th equals x. Type that in. What is e to the 5th rounded to the nearest hundredth? 0.41. Our e to the 5th would be our exact value if they had asked for it, and then 148.41. All right, number 3, we have a couple of things we have to do for our condensing. What's happening between the 2 and the x squared minus 25? Multiply. And then what's happening with the x plus 5? Division. So we have the log of 2 times x squared minus 25 over x plus 5 equals 1. So first exponential form, what's our base? What is it if there's no number written? 10. I wasn't writing 0, I was putting a circle like it should be here, but what number would be there? So it's 10 to the first, so 10 equals 2 times x squared minus 25 over x plus 5. Now somebody already noticed x squared minus 25 is difference of two perfect squares, so how would that factor? So then our x plus 5s cancel. So we have 10 equals 2x minus 10, because 2 times x, 2 times the minus 5, 2x minus 10. Add 10, divide by 2, 10. All right, last one for notes. What's happening between x and the parentheses? So they get multiplied. So ln of x times x plus 1 minus e equals 1. What's our base? E. So it's e to the first. And then I'm going to distribute my x, so x squared plus x minus ex. I have an x squared. That's always our hint. We're going to factor, so I need it to be equal to 0. So now what do? We do factor. If only we were taught how to factor 4 things. Oh my God, we were. Grouping. Oh my God. It's all connected. So what is our GCF within the first two? X. What's our GCF within the last two? Ooh, negative e. So our factors are x plus 1 and x minus e. So we get x equals negative 1 and we get x equals e. Can we keep the negative 1? No. So if I plugged it in here, I'd be taking the ln of negative 1. Not okay. Can we keep the e?